Did you know that the universe has no center? It's mind-blowing, right? This question is deeply rooted in our human curiosity. We instinctively search for centers, origins, and places to call home. But when we peer into the vastness of the cosmos, we discover something truly astonishing. There is no center. Our intuition often misguides us when we ponder the universe. We imagine the universe as a colossal sphere with Earth snugly at its core. But this is far from reality. The universe, as we currently understand it, has no edge and certainly no center. This challenges our perception and invites us to rethink our place in the cosmos. Picture an ant on the surface of an inflating balloon. As the balloon expands, the ant perceives everything moving away from it. But this doesn't mean the ant is at the center of the balloon. Similarly, we exist on the surface of our universe, which is constantly expanding. When we observe the cosmos, we see galaxies rushing away from us in all directions, like islands drifting apart in a vast ocean. This observation might lead us to a seemingly obvious yet misleading conclusion. It's natural to assume we're at the center of it all. Our vantage point makes it seem as though everything is moving away from us, placing us at the heart of the universe. But this is merely an illusion, a consequence of our limited perspective. Our position in the universe gives us a skewed view. Much like standing in the middle of a field might make you feel like you're at the center of the world. In reality, every point in the universe is moving away from every other point. This means that no matter where you are, it will always appear as though you're at the center of the expansion. Imagine hitting the cosmic rewind button and the galaxies all fly back to their origins. It's like playing a movie in reverse where all the actors return to their starting positions. But where is that origin? What is the starting point of this grand cosmic expansion? This question has intrigued scientists and philosophers for centuries. Enter the Big Bang theory. This concept provides a framework for understanding the origin and evolution of our universe. We often imagine the Big Bang as a colossal explosion occurring at a specific location in space. While this image is dramatic, it's not entirely accurate. The Big Bang wasn't an explosion in space, it was the explosion of space itself. Space and time began expanding from a singular point, creating the universe as we know it. This expansion continues today, with galaxies moving away from each other as space itself stretches and grows. The universe isn't expanding into something, rather it is the fabric of space itself that is expanding. So, while it may seem like we are at the center of it all, we are just one of countless points on the surface of this ever-expanding cosmic balloon. The true center of the universe is a concept that eludes our current understanding, reminding us of the vastness and mystery of the cosmos. Remember our ant on the expanding balloon? Picture it carefully as it walks along the surface, blissfully unaware of the monumental changes happening beneath its tiny feet. Now, imagine drawing dots all over the balloon's surface to represent galaxies. Each dot is a galaxy, teeming with stars, planets, and cosmic wonders beyond our wildest dreams. As the balloon inflates, the dots will move farther and farther apart from each other. This beautifully illustrates how galaxies drift away from each other as the universe expands. Now, imagine shrinking the balloon back down. The surface contracts and the dots begin to move closer together, just like galaxies would in a contracting universe. As the balloon deflates, the dots will get closer and closer together until they all converge at a single point. This convergence is a fundamental concept in understanding the origins of our universe. This is a simplified analogy for the Big Bang. The universe started from an incredibly small, hot and dense state, a singularity. Contrary to popular belief, the Big Bang wasn't an explosion that sent matter flying outwards into a pre-existing space. Instead, it was the rapid expansion of space itself. It marked the beginning of space and time themselves. Before the Big Bang, there was no space, no time, just a singularity of infinite density and temperature. In the earliest moments of the universe, everything we see today was compressed into an incredibly hot, dense state. This state was so extreme that it defies our current understanding of physics. As the universe expanded and cooled, matter began to clump together, forming stars, galaxies, and eventually planets like our own. This cosmic evolution took billions of years. But the expansion never ceased. The universe continues to grow, with galaxies moving away from each other at an accelerating pace. This ongoing expansion stretches the very fabric of space-time, shaping the cosmos and influencing the future of everything within it. The universe is a dynamic, ever-evolving entity, and its story is far from over. If the Big Bang happened everywhere at once, where can we find its remnants? The answer lies in a faint afterglow that permeates all of space, the cosmic microwave background radiation, or CMB. This radiation, discovered in 1964 by Arno Penzias and Robert Wilson, is a faint whisper of the Big Bang's energy, stretched out over billions of years. It's a snapshot of the universe as it was just 380,000 years after the Big Bang, a time when the universe was a hot, dense soup of protons, neutrons and electrons before atoms had even formed. The cosmic microwave background radiation is incredibly uniform, with almost the same temperature in every direction we look, just a few degrees above absolute zero. This uniformity is one of the strongest pieces of evidence we have that the universe began from a single, incredibly hot and dense state, known as the singularity. If the universe is infinite, does that mean we can see everything? Not quite. There's a limit to how far we can see, known as the cosmic horizon. This boundary exists because light from beyond it hasn't had enough time to reach us in the universe's 13.8 billion years. Picture yourself standing on a ship in the vast ocean. The horizon marks the furthest point you can see. You know there's more ocean beyond that line, but the Earth's curvature blocks your view. Similarly, the observable universe is a sphere centered on us. Its radius is the distance light has traveled since the Big Bang, making it our cosmic horizon. Within this sphere, we can observe galaxies and other celestial objects. But anything beyond this horizon remains hidden from our view, waiting for light to bridge the cosmic gap. While the universe as a whole doesn't have a center, every point within it can be considered the center of its own observable universe. This means that from any given point, the universe looks like it's expanding away from that point. Imagine another observer in a distant galaxy billions of light years away. From their vantage point, the universe would appear to be expanding away from them as well. From their perspective, they would also see galaxies receding in all directions, just like we do. They would also observe a cosmic microwave background radiation with the same uniformity as we do, indicating the same age and structure of the universe. This is the heart of the matter. The universe is isotropic and homogeneous on a large scale. The universe doesn't have a single privileged center. Instead, it is uniformly expanding in all directions. Every point is equal, every location as valid as any other. This principle is fundamental to our understanding of cosmology and the nature of the universe itself. Our current understanding of the universe is anchored in Einstein's theory of general relativity. This revolutionary theory has given us a profound framework to comprehend the gravitational forces that shape the cosmos, from the intricate orbits of planets to the mesmerizing bending of light around massive celestial objects. Yet there remain profound mysteries that general relativity alone cannot unravel. Take black holes, for instance. Their enigmatic nature, the singularities at their cores, and the unexplained phenomena observed in the far reaches of space continue to perplex and intrigue scientists. Enter theories like string theory and multiverse theory. These advanced theoretical frameworks strive to address the gaps left by general relativity, offering a more holistic understanding of the universe's fabric. String theory proposes a unification of all fundamental forces of nature, including gravity, by suggesting that the universe is composed of minuscule vibrating strings. These strings are posited as the most fundamental building blocks of all matter and energy, with their vibrations at different frequencies giving rise to the diverse particles and forces we observe. Multiverse theory takes this concept even further, proposing that our universe is merely one among countless others, each governed by its own unique set of physical laws. This opens up the tantalizing possibility of alternate realities, where the conditions and constants of nature could be radically different from our own. While these theories remain highly speculative, They offer captivating glimpses into the vastness and strangeness of the cosmos. They challenge our perceptions and push the boundaries of what we consider possible, inviting us to envision a reality far beyond our current understanding. These theories serve as a reminder that our current grasp of the universe is likely incomplete, and that countless wonders await discovery. As we continue to explore and study the cosmos, we may one day unlock the secrets that lie beyond the known, revealing a universe even more wondrous and complex than we ever dared to imagine. A universe that is constantly expanding and evolving. For some, it might be a disconcerting thought, a reminder of our own insignificance in the grand scheme of things. But I find it incredibly liberating. The universe doesn't have a preordained plan, no set path for us to follow. We are free to create our own meaning, to chart our own course through the cosmos. The universe is vast and mysterious, full of wonder and beauty. Let's embrace the unknown, explore the cosmos with open minds and curious hearts, and never stop asking the big questions. For it is in seeking answers that we truly discover who we are and what it means to be human. We have the incredible freedom to create our own purpose, to discover our own centers within the infinite expanse of the cosmos. What will you choose as your guiding star?